Good afternoon, everyone, and welcome to today's webinar. My name is Rami Fekhi. I'm the conference producer at Informa Markets Egypt, and on behalf of Sahara's team, I'd like to welcome you to today's session. This session, called Digital Transformation in the Agriculture Industry in Egypt and Africa, is organized by Sahara Expo and is in partnership with the Ministry of Agriculture in Egypt, with IFPRI and Prime Project. Today, we're going to be joined with three of the top experts of the field in the industry who are going to be sharing with us some extensive insights about the digital transformation in the agriculture industry. I'd like to remind you first that this webinar is designed to be interactive, so we encourage you to type in your questions and we'll try to answer as many of them as we can at the end of the webinar. And there's also a slight change in the agenda. Dr. Mohammed has a commitment, so we'll first start by Dr. Gulistan Radwan, and then we'll move forward to Mr. Mohammed Hirsch and then Mr. Ghazi. Dr. Gulistan, over to you.
Thank you very much, Rami. Just trying to share my screen here. I hope you can see it. Can you confirm if it's visible, please, Rami?
We can see it now.
Great, perfect. I hope the slides are also changing as I change them. Good afternoon, good morning, good evening, everyone. And thank you for the kind invitation to speak to you today. I'm just going to give a brief overview of what we're doing specifically in AI. I'm part of the Ministry of Communications and Information Technology. And of course, we run a whole host of digital transformation projects, but I'm specifically in charge of the AI file. So that's what I'll focus my presentation on today. And later on, I'm sure Dr. Mohammed Hirsch will also be covering broader aspects of digital transformation in agriculture. Just a very quick overview first of AI in Egypt in general, not specific to agriculture. Egypt has a very ambitious AI strategy that we've been working on for over a year now, on developing but also on implementing it. It really aims at two things. One is to exploit AI specifically to achieve Egypt's development goals for the benefit of all Egyptians. And then the second one is to play an active role and a leading role in championing AI issues on the regional and international levels. So this has to do with issues like the impact of AI on employment, on economic climates, on energy consumption and climate change, on the social aspect of things, but also ethical aspects of AI implementation. We translate this into a mission statement that says that we're aiming to create an AI industry in Egypt, including all the skills and platforms and technologies and enabling factors that are required to ensure its sustainability and competitiveness. The way we structure the strategy is in terms of the pillars and enablers that you can see in front of you, and I'm not going to dwell too much on them. Maybe just give you a quick overview of the pillars. So first we have what we call AI for government, which is using AI to make government operations more efficient and more transparent, whether that's government to citizen services or internal government operations themselves. The second pillar, which is what we're going to talk about in more detail today, is what's called AI for development. And it's really implementing AI in strategic sectors, but we emphasize development because we want to really stress the fact that we're doing AI for the sake of achieving Egypt's development goals. And then the third one, of course, is the human element, the most important in the success of any strategy. And then finally, in congruence with our second objective of the strategy. This is the international activities that Egypt participates in. And of course, you have the enablers like governance, like having the right data infrastructure, like nurturing and growing the ecosystem, and of course, having the right infrastructure and ensuring access to it by all stakeholders. As I said, today we're going to zoom in on the AI for development pillar and specifically on agriculture. So we've identified a number of strategic sectors that we want to proactively grow using AI, and agriculture is one of the most important ones. And we look at agriculture also in the context of water management, of environment, of reforestation, and so on and so forth. So let me just give you a quick overview about some of the application areas that we're looking at. Some of these are already active projects and some are still ideas that we're evaluating. But in general, what AI is used for in agriculture can be, among other things, in terms of complete automation of the agricultural value chain. So this is actually having agricultural robots on the ground that can also be autonomous to handle essential tasks, everything from harvesting to removing weeds to fertilization and so on and so forth. This is, of course, for countries or for organizations that want to specifically reduce human labor and increase efficiency at very, very high volumes. A second example is monitoring applications, like, for example, crop and soil monitoring, where we leverage technologies like computer vision, like deep learning algorithms, to process the data captured by whatever imaging technology, so that we can keep track of the health of the soil and the crop. And this can also be done in conjunction with IoT or Internet of Things applications, where we have sensors on the ground to be able to monitor soil condition and report back and optimize for the growth of specific crops or for certain stages of the life cycle of a crop, also interpolating it with things like weather conditions and the like. And then the third example is predictive analytics, where we use machine learning to learn from historical data, so we can predict various scenarios. For example, the impact of changing weather patterns, of changes in soil salinity or humidity, or even in changing crop types on crop yield and soil health. This is an example of a project that we're currently working on, which is a smart farmer's assistant that is supposed to help provide advisory to the farmer on various things, from choosing the right crop to when to plant, when to irrigate, when to harvest, to market pricing and answering questions on things like pests that might be attacking some of the crops and how to combat them, or when to fertilize, what's the right type of fertilizers to use, and so on and so forth. The next one is the detection of agricultural land boundary and crop types. And this is really important in Egypt because we have, especially in areas like the Nile Delta, we have, as you can see on this image, very, very small plots of land, which are very roughly delineated, and it's really difficult to detect the boundaries. And you'll find people planting rice next to maize, next to whatever else, and it's extremely difficult to then utilize any kind of nuanced irrigation techniques or anything like that, because everything is so closely packed and difficult to distinguish from each other. And what this application does is it uses satellite imagery to detect those boundaries between very, very small plots, even, as you can see, and then it starts trying to detect the crop type and growth stage that it's currently at. And using that, we can infer any number of things, including, for example, what are the exact water needs in terms of irrigation? When do I need to irrigate? How frequently? By how much? And so on, in order, again, to preserve soil health and at the same time maximize crop yield. So this is a project that we're actively working on. We finished the pilot and we're rolling it out now at a larger scale. The next one is change detection, basically. So detection of erosion by seawater, for example, or illegal buildings on farmland or anything like that. So this is basically around detecting any changes in agricultural land that might occur, again, using geo-AI and computer vision techniques. The next one has to do with palm trees, or really any kind of trees, where we try to count them. Of course, Egypt is probably the largest producer of dates in the world, and we have millions of palm trees, and as you probably know, palm trees are some of the most susceptible to certain types of diseases, and they spread very fast and are very difficult to contain. And so being able to constantly monitor from afar the overall health of vast areas of palm trees, and in the future other types of trees as well, is highly beneficial, so that you can detect any change in health and intervene quickly. The next one is, again, an AI plus IoT type implementation. This is, what we generally refer to as precision agriculture, which is that you try to monitor every aspect of a plant's health, including soil, including water, weather conditions, and so on and so forth. And you try to customize how much water you add to it, how much fertilizer you use, of course trying to minimize the use of chemicals, if there are any pests or anything like that, that you can detect them early, and so on. So this is, again, something that we're currently evaluating for specific types of crops. Of course, these types of technologies aren't generally very cheap, so you have to have the right business case for which type of crops are eligible for or lend themselves to using these technologies to maximize crop yield. The next one is spot spraying and pest detection. Of course, blanket spraying of pests is a huge problem. It reduces overall crop yield and quality. And of course, it also damages things like compliance with regulations and standards for example, organic produce and things like that, and also export requirements to some countries, and even domestic consumption standards for Egyptian markets. And so, in addition, of course, to damaging the environment and wasting lots of chemicals and stuff like that, so finding ways to specifically detect single areas of pests and weeds and problems and target them using spot spraying technology. This one is done via drones, but it can also be any combination of things, like it can be aerial photography to detect and pinpoint exact locations of pests, but then you can even go down in the field and spray them manually if you want. So it doesn't have to be an end-to-end automation of the process, but it's a way of identifying exactly which parts are infected quickly and easily down to the specific leaf of the plant, and making sure that you don't use more pesticides or chemicals than needed. This one has to do with supply chain management and prediction. So this little kind of beach buggy-like vehicle here, developed by a Spanish company, specifically goes through the fields it's more used for fruit trees, oranges and lemons and stuff like that. And it counts the number of fruit on the various trees so that you can have an estimate of your crop yield this year and can start planning in advance how many people, what kind of resources you'll need for harvesting, but also your entire supply chain, and how you're going to get all of this to market, what you're going to sell it at, and so on and so forth. Then we get into a really important area, which is livestock management. And this is another important and very kind of ambitious project that we're embarking upon, which is basically how do we optimize the entire life cycle of an animal from the day it's born to the end of its life, and how do we detect any diseases or illnesses and combat them early? How do we optimize, for example, for insemination periods, but also feeding times and quantities and types, and how do we maximize things like milk yield and so on and so forth? And again, this is an AI plus IoT implementation by using sensors on mounted on the animals to detect vital signs and track things like movement and body temperature and so on. So yeah, this is basically these are the kind of types of sensors that we're looking at, which can range in sophistication from simple ear tags to really implantable chips that can detect pretty much every vital sign within the animal. So this is just a quick overview of the types of projects we're looking at, but in general, what Egypt's AI strategy is about is really about including these projects within an entire continuum that starts with building human capacity. So we start with our capacity building programs, whether it's for technical or non-technical people. So for agricultural experts, for example, to take AI 101, IoT 101 type courses so that they know the importance and the benefit that these technologies can bring to their field, and how do you identify a project that's suitable for AI implementation, how do you collect the right data, how do you evaluate the results, and so on and so forth. And then when you start working with technical teams, you can really build a connection quickly and work together efficiently. Of course, all of these programs are underpinned by partnerships, academic and industry partnerships, and the infrastructure that we talked about in the enablers. But once people finish these programs, they have to have a path. They have to have a way of applying what they've learned to learn more, because in AI, there's always a huge discrepancy between what you learn in theory, even if it includes a practical component, and real life, an end-to-end production-grade project. So we need people to be able to go into some of these projects, like in agriculture, like in other areas of strategic importance to Egypt, such as healthcare, infrastructure, smart manufacturing, and so on. And we implement these projects with the help of our technology partners, both in Egypt and abroad. And of course, with the help of the data sets that we're trying to collect using the various digital transformation efforts that the country is embarking upon, and which I'm sure Dr. Mohammed Al-Irsh will get deeper into. Once people have one or two of these projects under their belts, then they can join the ecosystem and help grow it, whether by starting their own companies, building, going to an already existing company in the private sector, staying within government and leading the next wave of projects, or even going into research and academia. And once that starts happening, then the ecosystem starts growing. And that's how we close the circle, basically. So once the ecosystem starts growing, that stimulates more demand for qualified individuals, therefore requiring us to increase our capacity building programs. So this is kind of the virtuous circle that we're trying to build in order to really kickstart Egypt's AI industry. That's all from me. Thank you very much. This is our website in case you'd like to have a look at what we've been up to. And thank you very much for listening.
Thank you very much, Dr. Golistan, the advisor to the Minister of Communications in Egypt. I know it was kind of hard for you to join us today, and we're very thankful for your time. Thank you. And I would like to present Dr. Liang Ziyu, because Dr. Muhammad is still delayed. If Dr. Yu, would you be willing to go ahead now?
Sure. You put the slides on, or I want to share screen?
No, I put the slides on, and you now have the control.
Okay. Just give me one moment. Haven't showing up on my screen yet. Wait. Okay, here we go.
Click on the slide before changing it.
Okay, thank you. Thank you to have me. It's glad to be here to the very important forum on this smart agriculture. And you can see, I have two titles. I'm part of IFPRI, is International Food Policy Research Institute based in Washington, D.C. But also I have another role. If you can see on the right side, is this. You can see this Chinese called Mary. This is now is one of the universities in Huazhong Agriculture University, in famous Wuhan, China. So, and then this is Mary actually is joining institute between the IFPRI and this Huazhong Agriculture University. So you will see, and then today I'm going to talk about sorry. Oh my God. I cannot go up, huh? Okay, here we go. I want to give you a little bit overview about what smart agriculture is, maybe from this slide, and then what I'm trying to do, and then on the smart agriculture, give you a little bit overview, and again, as I introduced, use China as an example. I even intended to use a few, I didn't change it even in Chinese, and then I will go a little bit deeper into what we like IFPRI and this my team is actually doing, very specific what we do in actually do in the smart agriculture part. Actually, it's related to this crop kind of detection and yield estimation part, and then the smart agriculture. Actually, if you look at the little bit history, look at it, agriculture development. We started with slash and burn agriculture. If you look, traditional agriculture, we started with slash and burn. Now we have like a draft animal to help us out, and then you go to more like a mechanized agriculture, and then biochemical agriculture, as you see. But that too is kind of mixed. This is so whole green revolution. Everybody knows. That is about. Now we are looking at smart agriculture. Smart agriculture, what is data driven? And then if you look at the picture on the right, this ideally, I think I take this picture from one of the papers I saw. And the future farmers, you can see, it seems like I'm glad Dr. Radwan actually presented quite a few very nice application. In the future, it seems like you can, like you and me, just sitting in the office, just click a button to do it. But now, this is the future. Of course, it's not realities. What from that future, we have still a long way to go. And then the key in all of this, actually, it is the data driven. It's a data driven farmer. We need the data, driven. And here, intentionally, I see what it means by data. Intentionally, as I said, this is actually I take from my, I don't, I know you don't know. I don't expect you to read Chinese, but that the picture actually give you what I'm trying to say. Here, in central is a data platform. It's a data platform. This data from all kind of things. On the left side, on the screen, it is all the data, from the IoT things, we are talking about on the sensors from the field, from the drones, from the car carried kind of sensors, and from satellite, even from your own server. Remember, still, even with all the advantage of satellite or our phones, we didn't use the old-fashioned way to do the field validation is important. If we put all the field data together, and then of course you have this machine, intelligence, machine learning, deep learning, and the intelligence part. and put all this data together. On the right-hand side, you can actually do some decision making and service. I'm glad, again, I referred to my previous panelists talking about this application. And for example, you can detect diseases, you can do the precision agriculture, not just flooding the whole field, rather than only irrigate what, maybe up to the individual crop level. And even the spot spray is another example. Of course, you can have this crop harvesting, or automated. And then, of course, you have this insurance. I think it did an insurance part, and then, so you can have this resilience. This is one part. And then this is centralized on this data. The smart data, the big data is the central part of the whole thing. And then again, if you look at the whole picture, this is actually again, I use China as an example. If you look at the data, where's the data come from? The big data is just the sky. From the sky, this is where satellite, we use the international satellite also. I'm not sure Egypt or other, but China have the own satellite, the own satellite can serve agriculture. Of course, they serve a lot of defense, other, industry use, but agriculture is one of the biggest application. Another part is, this is, you can see again, just use the picture, is the drones and even airplanes and the cars related this smart systems. You can go around, and the advantage of the satellite is it can cover a lot of large area without very low cost. Of course, this from the drones is much more expensive. You can do the spot check. And again, another part, this is where the IoT comes or the sensor comes from the field, right? From the field. So in the Chinese, it's 天空地, right? It's from sky, from the air, and from the field. And then from all this data together, that is important. Remember, we have to have this data, and then from this data, we can actually have the smart agriculture. Again, I'm trying to emphasize that data is a key for any smart agriculture. And here actually is one of the systems I don't know, somehow the validation didn't choose. If you can see the car, this is a picture actually we take from the Chinese Academy of Agricultural Science, where they actually do have this, so-called modern farmers kind of, if as example to demonstration the technology, how the technology can use it in the real farm. And then you can see you have the drones in the air, and then you have the cars driving through, and then you have all the sensors in the field, and then you have some kind of tractors in the background. We actually, this is, I think, is rice field. No, of course, this is actually ideal world. I don't think is, in particular case for our today's forum on this application, smallholder agriculture in mostly Egypt and in Africa, the smallholder. I think it's still a long way to go. Even in this large scale farm like US, like Europe, it's still, I mean, it's not the ideal kind of smart farm agriculture, smart farm yet. So particularly, I think what I'm trying to, again, I focus on data. I double this statistics from space because this is what I did in almost now 15 years ago with Gates Foundation, when Gates Foundation trying to do what Gates Foundation can do with smallholder farm, again, with smallholder farmers in mind, what they can do to advance the smart agriculture. Again, what they identified, the first thing is actually get the data, get this basic data of agriculture area and yield and even some diseases detection. So we have like get all the peoples around what challenge you, what they want, if you want. Again, I focus on this on the Earth science data, Earth observation, just satellite based data. So if you when we do the survey around the world, again, and in the context of smallholder agriculture like Africa, in African agriculture. So what do you want? If you want some data from Earth observation data, what do you want? What is your wish list? And then this is what survey from hierarchy. You can see the third. Oh, if I get a cropland, would be great. And then if you want a little bit more precise if you can separate permanent land, permanent and from arable area, and then if you can separate rainfed irrigation, and then if you can actually satellite can tell us growing seasons, growing season, and even crop pattern in the even the last part. Remember, this is 15 years ago. I mean, of course, even now, they said if we can crop specific area yield distribution, that would be great. It's because that will have us for planting, investment, and even precision agriculture helping a lot. Because remember that is a large scale in the even continental level or at least the country level, get this real-time crop specific area and the yield estimation would help the smart agriculture a lot. So this is where I'm going to a little deeper, where the frontier right now, what do we do? So that is actually, I'm showing another picture. This is one of the, again, Gates Foundation put money where their mouth is. They actually funded one of the project, with University of Maryland, with the CGR centers, doing 2 cases, actually 3, you can see the Uganda, Rwanda, and Tanzania. Look at this very small scale. So how realistic from use advanced technology, you can see the picture from the satellite data, from this even the commercial satellite like Planet Lab data, UAV data, field data, how realistic we can get this so-called statistics from space. To be honest, actually, it's not easy. It's even now we have the high technology, but the end is not easy. Again, what we realize, the crop area mapping is fundamental. If you want to distinguish crops, in particular very small, very complicated land, as my previous speaker said, you can see smallholder farmers. It's very tiny plot. They are growing, maize beside rice. Even detect the plot boundary is hard. So actually, this is where we are doing use a lot of this, again, the big data, satellite data. This is one of the papers. We did it together with University of Maryland to look at this maize area in United States. This area. Another part of even area is hard. Yield is even harder. Yield actually is battle luck. This is one of the papers. Is my collaborators in Stanford University is actually presented very nicely on this satellite based and yield variation. Again, in the smallholder content Africa system, actually they are estimate the yield within Kenya. Maize yield is Kenya, very small field. And then they build something very nicely over there.
I'm sorry to interrupt. You have 5 minutes left.
Okay, I'm trying to speed up.
Great.
Somehow the technology is not, I'm going down. Somehow it didn't going down. Can you just flip? Okay, here we go. Here, I'm showing a paper I did with it. This is one of the things we use. Of course, I don't want to go too technical. We use this a new satellite image. It's called coronal fluorescence. This SIF data to actually is better in the typical NDVI to detect the crop yield. And here is another project we actually working together with. It's called the Lhasa Harvest. You can see the website. Actually, IFPRI is part of the bigger consortium to look at it again as smallholder agriculture context. To look at the space agency, how the space agency like Lhasa can help smallholder agriculture to decision making. This is actually 15 minutes Lhasa Harvest project. Look at this how the space agency's data can help the agriculture. Somehow I have technology again. Can you move it? Okay. This is another work we did with a German, this IDIF. Here is another we call the Lucky Lag. Look at this again. Look at land use change knowledge integration network. We are trying to develop the grid data product. Almost look at this. I mean, one of the detection of change in a global scale. Another initiative, this is actually very late initiative, is data to end hunger. Actually, this is led by World Bank and IFPRI and FAO to actually combine traditional survey data and with the satellite data to the idea is by 2030 we're trying to in 50 this development countries build a kind of more like a real-time, more like statistical space kind of approach in this initiative. Again, also there are a lot of companies, a lot of a startup company actually doing the Stanford University Atlas AI is one example. Another example is the Cars Lab actually doing. You can see the picture over there. They actually go to, this is actually pure startup, but venture capitalists. They see the opportunities in smart agriculture. Again, provide the data, crop kind of things. Again, finally, this is my final slide. Actually, this is what we do. In my team, actually, use the big data and the machine learning to look at the smallholder crop type yield estimation. In this case, we use South Africa and Ethiopia. You can see the picture. Of course, we use mostly freely available data. This is European Space Agency Sentinel and the US NanoSat data, and with some, of course, field validation. If you can see the prediction yield and the real yield, it's not ideal, but you can see R squares around 0.7 or 0.6. It's okay. We can, we are in that stage where we actually can move the smart agriculture close to the promised land we showed in the first few slides. I think I'll stop here, and I'm happy to answer any of you guys your questions.
Thank you very much, Dr. Yu. We'll be going to questions afterwards because Dr. Mohammed is going to do his presentation now. Just if you can give me a second.
Hello, my colleague. Is my sound clear now?
Yes, Dr. Mohammed, we can hear you. I see you.
Yes. So first of all, thank you, my colleagues, thank you, and thank you, Dr. Christian. Actually, we have a lot of efforts in the last few months to improve the digital transformation unit in the Ministry of Agriculture. Actually, we have a lot of efforts, as Dr. Sadi mentioned. We made some application, and we are going to make other applications that will support the farmers here in Egypt. Actually, hudhud application and the application for the livestock production. All of these applications are going to be implemented in Egypt, and I will not go through this application because actually Dr. Sally gave a full description about what's going to be happen, but I will give you some notes about what is the efforts of the Ministry of Agriculture to implement a unit for digital transformation. Actually, let me firstly mention that this is the second webinar which is dealing with, which is organized between Sahara Expo and also Prime Project. This expos and this webinars are going to be implemented to improve the capabilities of the farmer. Actually, it is a part of Izra Sah campaign. If you see the logo, Izra Sah or Cultivate Light, this campaign have been implemented by Prime Project, which is funded by IFPRI, the International Fund for Agriculture Development. Actually, this campaign is used or is hosted by Prime Project to improve the capabilities of the smallholders to produce and to cultivate more better crops, which gain and which give them more income and improve their income. And that is a part of the aims of the Ministry of Agriculture overview and vision. So let me go through my presentation. We are going to speak about the digital transformation unit of the Ministry of Agriculture and Land Reclamation, and it's me, Mohammed Al-Qarsh, the assistant to the Minister of Agriculture and the head of Prime Project, also, which is having Izra Sah campaign. So could you give me a second slide, please, Rami? Next slide, please, Rami. Okay. So that's an overview for the digital transformation unit. Actually, all the ministries in Egypt are going to improve its efforts to have more development in the digital and the digitalization of their workflow, so that we have implemented a unit for digital transformation in Ministry of Agriculture. This unit have been implemented in cooperation with the Ministry of Information Technology and Communication, MCIT. This unit contains or consists of 20 members. These members have been interviewed and examined to be able to know their abilities to have an overview for digital transformation by the MCIT. And then they have been joined our work, and we have 3 main pillars. If you give me the second slide, please. Rami, next slide. Yes. We have a vision. Our vision is related to the strategy of Egypt, Egypt Vision 2030, and also is related to the SDGs for sustainable development of the world, the national SDGs. Actually, we are going to upgrading the services and management systems in the Ministry of Agriculture. That's our vision. And our mission is to agriculture, our mission is to transform the and provide digital services for the benefit of its clients, for our clients in the Ministry of Agriculture, in addition to providing research-based advice to support the policymaker and decision maker to ensure a secure and proposes food future for the benefits of Egypt as well as the rest of the world. Could you give me a second slide? Sure. So in Egypt, we have the Minister Office, which is organized by the Minister itself. Then we have the Digital Transformation Unit, which is supervised by the Minister itself. And then we have 3 main pillars for the work in the Ministry of Agriculture. Actually, we have 17 employees, as I mentioned before. We have 3 main pillars that are working with them. The first main pillar is workflow and government services. Actually, in this pillar, we are going to improve all the services that have been applied by the Ministry of Agriculture. Actually, we have about 130 services. All of these services are going to be automated. And so the farmer and even any citizen could have the services that have been applied by the Ministry of Agriculture directly through application or through the Egypt Gate directly, and then got the services. Also, we are very interested in using the GIS, Geographical Information System, to have more reliable data and more accurate data for what's happening on the field. Actually, we made a lot of efforts in this department. We use the artificial tool to collect the data and to give a dashboard for the decision maker and to policy maker to detect what is the cultivated area and what is the crop that have been cultivated. Actually, we have a lot of efforts with MCIT and Dr. Sari Radwan, especially give us a lot of efforts to make this application available for the Ministry of Agriculture. And this made by Microsoft and IFPRI companies to let it go live. Also, we had a lot of efforts to improve the capabilities of the worker in the Ministry of Agriculture to use the GIS. And so we made a lot of training courses and capacity buildings to the workers in the unit of the digital transformation. On the other hand, we have the third pillar, which is aiming to forecasting and foresighting and let the policymaker knows what's going to be happen in the future regarding to the investments in nowadays and the decisions that have been taken nowadays. This depends on an artificial intelligence tool also. This tool taken in consider the social and the economical and the livelihood of the current situation. Also, what's going on the worldwide. Actually, it's called IDA model, and this this pillar is going to be developed and well implemented with the support of IFPRI Institute, which is a part of CGIAR Center. So can you give me the second slide? Okay, so for the first pillar, we have many issues to be developed. Actually, we are going to improve the workflow and to develop the workflow to be automated. Also, we have some capacity building for the worker on this department. Also for maintenance and for development and research and development. So we aim to implement this pillar within 5 years. Actually, we started already in 2020. Now we are going to improve about 20 services that will be live, will go live for the farmers and for the citizens by the mid of 2021, and then going through the activities up to 2025. Also, the second pillar is to using the GIS. Also, we have many efforts that have been applied, actually collecting of the data regarding to what's happening on the field from satellites. We are collecting now the images from satellites with resolution about 3 meters, and we are going to improve this resolution. We aim to reach up to 30 centimeter only, and this will improve the production and the prediction of what's happening in the field very well. The third pillar is for forecasting and for detecting what's going to be happen in the future regarding to the current situation. Actually, we have nominated the members of this group. Also, we made a tool with IDA model. It's going live today, and it's funded by IFPRI and implemented by IFPRI Institute. Now we are going to improve the capacity building for the worker in the unit to be able to use this IDA model, and this will be very supportive for the decision maker. Next slide, please. Okay, what's our objective? We are aiming to increase the productivity of the farmer, especially the smallholder. Actually, the smallholder have a lot of losses, have a lot of waste during his production because of the dividing of the land, and it's not as huge as on the other countries. So we sometimes found a farmer cultivating only 100 meters or 400 meters only, and this is very small area to be cultivated. So using this new technology and collecting and make collective farming will be very helpful for these farmers. Also, it will give fast delivery for the services, because when the farmer need to have any service or any thing from the Ministry of Agriculture, he will just click on mouse or click on the application, and then it will be delivered to him. And also we have SLA to be sure that all the services will be reached on time to the farmer. Also, we are going to improve the capacity building. Actually, we are going to move to the new capital, and this needs to improve the capabilities of the worker and service providers in the Ministry of Agriculture. Also, it will give us reliable data, accurate data, and this very important thing should be developed, and we are aiming to develop it as soon as possible. Also, we will be sure that we will have a good investment because of the prediction of the future regarding to the all the situation, all the current situation, and what's going to be predicted in the future. Also, it will give us very good investment. Also, for forecasting of the weather and of the future regarding to the mandates that have been applied today. Also, and it's very important thing, and I let it for the end of this presentation of this slide, is the governance. Making all actions that have been applied by the Ministry of Agriculture is governing and make governance for all the workers in the Ministry of Agriculture. This is very important thing because it make all the efforts that have been applied and all the workers and service provider efforts make it very direct to the consumer, to the farmer, and make the farmer very happy from dealing with the Ministry of Agriculture. Next slide, please. Our priorities. We are aiming to prepare a dashboard to collect or to let the decision maker see all the transactions that have been applied in the Ministry of Agriculture. Please, next. Notification. We are aiming to have a notification to notify the worker that he has a task should be applied. Also, we should make notifications to the farmer itself to let him know that what is the current situation, what should be applied on the land each morning, each day. Should receive some information about the current situation, about the weather, about what should be applied on the land, what fertilizer should be applied to his crop, what should be applied on the land, and it's very important also to improve the productivity of the farm. Also, we are aiming to improve the workflow for the services, because actually now we are depending on the paper workflow. Now we are going to improve this paper workflow to let it paperless and to depend on the new technology. And so we need to re-architect the services, and now we are going to make it, and we have some deals with MCIP to make the re-architecture of the services. Also, again, it will make governance, easy farmer life and communication. And this is the aim of the digital transformation unit. We need to have governance for all transactions that have been applied by the Ministry of Agriculture. We need to let the farmer life be easy. We need to improve its life. And this is related to the presidential initiative for Haya Karima and for development of the rural areas in Egypt. Actually, the Egyptian government spent a lot of time and a lot of efforts to improve the life within the rural areas. And finally, we need to develop and to improve the communication of the Ministry of Agriculture, either internally or externally, to let it be easy to find more communication with the farmer. Actually, we made a hotline to have contact with farmer directly, and also through Izra Saha campaign, we make very fast action and fast response to all the action taken and all the questions that have been sent by farmers to us. Next, please. So our action plan again is to detect the 16 expertise. Now we have 17 expertise. Also to make to improve the skills of the workers to be able to use the IT, information technologies, and the GIS systems and agriculture economics. And this is very important to let all the workers in the transformation, digital transformation, to know the economy it's very important to know the economy and know the agriculture economy, because it's very essential to let all the actions that have been applied is very economic and be more better. Finally, the digital transformation, the digital information unit is building the capabilities of the workers in Egypt to be able to move to the new capital of the Ministry of Agriculture, and this, I think, it might be as soon as possible, and also to develop the irrigation methods in the farm itself. Next, please. Finally, for forecasting and foresighting that it might be supported by the EU and every institute, we are going to improve it through 3 steps. The first step is to establish the team that's able to work in this HIDA model. A second component is to respond to COVID-19 and to have more modification and more development and more trainings to how to deal with the current pandemic. The third component is to improve the database and digital database to be able to make statistics and to be able to make some studies to forecast the future. The long-term view is to establish and foresighting the economic, socio-economic foresighting model, and to be implement this model and to use the database to develop it. Finally, this team will be embedded in the digital transformation unit. I think I finished my presentation, and thank you so much. Thank you, my colleagues. Any question is welcome from me. Thank you.
Thank you very much, Dr. Muhammad. Because of the time, we have just enough time for one question for you and one question for Dr. Yu. Unfortunately, Dr. Gustan had to leave, but we have agreed that we will take the questions from the audience, send it to her, and then if we can get the answers, we'll send them to you. We'll do the same with all the questions for all the speakers. For now, we'll just take one question for Dr. Muhammad and one question for Dr. Yu. So the question for Dr. Muhammad is, are there any training programs carried out by the ministry to train and educate the farmers about the new technologies?
Rami, I have an issue with the sound. So could you repeat the question again?
Yeah, sure. Are there any training programs carried out by the ministry to train and educate the farmers about the new technologies?
Yes, actually, we have many trainings for the farmer to use the new technology. Actually, we have electronic farm schools nowadays is being implemented in many governorates, especially in many governorates. We have implemented many trainings to use the technology. Also, we have some trainings through online way or through social media. If any farmer can join us on Izraq Sahhi campaign, he will find many trainings and how to use the new technology in easy way and in a simple way that is also we have some dramatic films or movies that could be give the farmer the idea in a simple way and a dramatic way. Also, we made the campaign in electronic farm schools, and it's very essential. Also, we have many farmers, especially girls, have been trained for entrepreneurship and for using the new technology in the farm. Also, we have some trainings on how to use technology in the agriculture sector, especially the organic agriculture. We are aiming to improve the capabilities of the farmers to use the organic way of cultivation.
Thank you, Dr. Muhammad.
Thank you.
Dr. we have time for one question. How can smart agriculture preserve water waste in countries that still use flood irrigation methods?
Wow. Okay, this is actually a very good question. I know in Egypt, the irrigation is part of it. I said, again, this is related to precision agriculture. Again, this is data. You remember the flood irrigation just because we don't know what the actually crop needs, right? If we actually know the technology, so this actually allows the satellite can have the soil moisture. It's actually soil moisture, right? What you can actually detect what each crop needs. If you look at the technology, irrigation technology, drip irrigation is one of the technologies, right? Invented before even the current agriculture. So we will go a long way because of the smart agriculture, because of precision agriculture, because of the big data. We actually know, the precisely when the irrigation needed and precisely how much water is needed. And even, if we go to, again, look at the drip irrigation analog, we can also go to specifically which crops, which kind of plants it needed. In that way, because remember, data is very cheap. If you just fly the drones over, and then you can see, or you can see, where, which individual crops needed. So this will save a lot of water. And then, of course, save water is not just save water, also a lot of other problems because of flood irrigation.
Great. Thank you very much, Dr. Yu. I'd like to thank our speakers for joining us. I'd like to thank the audience. As I said, we will communicate the rest of the questions to our speakers, and we will post the answers we get along with the recording of this session on our social media page. I thank you everyone for joining us, and have a great end of day.